Today I'm going to show you an example of how to do standard deviation and variance. As you can see, the formulas for variance and standard deviation are very simple, and that's because the standard deviation equals the square root of the variance. We'll get into explanation as to why they are so close as we get closer to the end of this lesson after we get into some calculations. So let's go ahead and get into it. Standard deviation and variance look very threatening. They're really not bad as long as you take the proper steps to organize your data. And basically, the standard deviation, all it is some sort of mean distance each of our scores are from our sample mean. And this may not make much sense now, but hopefully it'll make more sense by the end of this lesson. So the formula for the standard deviation, remember this is often symbolized by the lowercase s or the capitalized SD, is equal to the square root of the sum of squares divided by the sample size minus 1. And we're going to go ahead and break those steps down with a specific example so you can see what these different things mean. I know it sounds like some alien language, but hopefully it won't very soon. So your first step when you're looking at your data is you're going to have to find the mean of your sample. In order to do that, you need to add up all your x's and then divide by your sample size. So here, if we're going to add 0 plus 3 plus 2 plus 1, we're going to get 6. So we'll put that right there. And that is our sum of our x's. If you notice here, there is a summation symbol. It's the sigma right here, not with the x, but if you just look at the symbol, that symbol just tells you that you need to add up everything that's behind it. So in this case, it's saying the summation of x, so it's saying add up all of your x's, and so that's where we got our 6. So in order to find our mean of our x's, we have to take that summation of our x and divide it by the number of participants in our data. As you can see, we have 1, 2, 3, 4. We have 4 x's here, so that's going to be 4. So for here, you're going to have 6, which was our summation of x, divided by 4, which was our sample size. And when you do that, you get our mean is going to be equal to 1.50. And that's because when you take 6 divided by 4, you're going to get 1.5. I always round all of my data to the nearest 100th place, which is 2 places past the decimal. And that's so when I get into heavier calculations later into the semester, I'll already be in that habit. Okay? So here, I'm going to go ahead and list the mean, because the mean's not going to change for our sample size. And this will allow me to work on my deviation scores. So if you see here, the next step in our formula in using this table is to take each x and subtract it, subtract the mean from it. So here you would have 0 minus 1.5, and you're going to get negative 1.5. Okay, so you're going to continue to do this for each of the scores. Again, each of these scores are called the deviation scores, and they're called that because we're seeing how far our data point deviates from the mean, or how far off it is from the mean. So here our x is 3, and we're going to subtract our mean, and we're going to get a 1.50 again. This time it's positive though. Next, we have an x of a 2. We're going to subtract our mean from that. And so 2 minus 1.5 is going to be 0.5. And then our last one is going to be 1 minus 1.5. And here we'll have a negative 0.5. And so something that you're going to notice is here you'll see another summation symbol, and it's saying, hey, let's add up all of these deviation scores. Like I said, statistics is more of a language than it is learning any new math skills. You're just going to use math skills you've already learned. And so we're going to add up all of our deviation scores. You're going to notice that negative 1.5 plus 1.5 plus 0.50 minus 0.50 is going to equal 0. Okay, and that's good. If you get a deviation or a sum of deviation scores that is not 0, you made a calculation error. So I always tell my students, make sure that you go through, you figure out these columns correctly, and then you always add them up to make sure it's 0. Sometimes you'll get 0.02. That's if you have some crazy numbers where you're doing a lot of rounding. Sometimes it'll be a little bit off, but usually you should just get 0 here. And because of that, you really can't go through and find what the mean distance is each of the scores are from the sample mean, because if you add them up and you have the 0 and you divide it by 4, you're just going to get 0 for every time. So that's why we have to go into this column now, and we have to square each of the deviation scores. Okay, so we're going to find that. So to square negative 1.50, you're going to have to take negative 1.50 times negative 1.50, and what you're going to find there is 2.25. Again, you're going to then find the square of the deviation score, so you're going to take 1.50 times 1.50, and you're going to get 2.25. And you're going to continue to do this for each data point. Here we have 0.50, and we're going to multiply it by 0.50, and we're going to get 0.25. And then we'll get into this column, and we'll have a negative 0.50 times a negative 0.50, which we will get will be 0.25. Notice in this column there are no negatives. Remember, anytime that you square a negative number, it's going to be positive. So if you ever have a negative in this column, you did something wrong. So make sure you go back and check it for yourself. So now you see we have this lovely summation symbol again. Remember, this is telling you to add up everything behind it. And it's saying add up all of your squared deviation scores. So this right here is also known as your sum of squares. Sometimes they represent that by an SS. That's just something to keep in mind for the future. So we're going to do what it tells us to do. It says let's add up 2.25 plus 2.25 plus 0.25 plus 0.25, and I get a total of 5. So what we're going to do is take that sum of squares number and we're going to plug it back into our formula. So let's copy our formula here. Okay, so we did all these calculations and we found that that is 5. And then it's asking, okay, so what's your sample size? We know that we have 4 participants, so we put 4. And basically now all we have to do is solve for our standard deviation. So it's saying you need to take the square root of 5 over 4 minus 1, which is 3, right? Equals, so then we got to show all of our steps in our work, and we do that so that I know where you make your mistakes so that I can help you. The next step would be to divide 5 by 3. So 5 divided by 3. And that's when we start to get into some funny numbers, right? So the actual number is like 1.666666666, repeating, right? Never ends. So what we're going to do is we're going to round to the nearest 100th place. If you notice, this 6 is above a 5, so we're going to round the 100th place up to 7. So when you're doing your calculations, make sure you're always rounding to the 100th place, which is 2 places past the decimal, or it's going to throw all of your calculations off. Okay? So then we're going to take the square root of 1.67. Okay, so get my calculator in order. 1.67. Square root. And I get a big, long, crazy number, right? 2, 2, 8, 4, 7. And I'm going to round that to my nearest hundredth place. And I'm going to go back because the 2 was under 5, then we don't round up the 9. So your standard deviation for this example is going to be 1.29. So if you notice in the formula, I said that we are basically seeing some sort of mean of the distance each score is from the mean, so about how far apart are the scores spread out from the mean. And we did that, and we had to square it here because the deviation scores, because we had the total of 0, which means you couldn't divide it by the sample size and get a good, accurate representation of how spread out your sample is. So when we did that, we had to take the square root to get it back in the same form it was originally because we had done the squares. And that's how we got our standard deviation. If you notice in the formula, if we would have stopped at this step and not taken the square root, we would have had our variance. See, if you notice here, remember our standard deviation equals the square root of our variance. So I hope that helps. Please let me know if you have any questions, and I look forward to helping you with this unit.